this video, we discuss episode 2, division for SM 05 for the second part. Okay, this one consists of three topics. Probability. Okay, this probability. 2 questions. Okay, then topic random variables. Also 2 questions. And the last is topic 10, spatial probability distribution. Also 2 questions. We will discuss 6 questions for this episode 2. Okay, for number 1, given probability of A is 0.5, B 0.6, probability A union B equals 0.8. Calculate the probability that both events A and B occur. Hence, verify that A and B are independent. So, to find both event A, B occur, B, A intersect. So, to find B, A intersect B. Verify that A, B independent. So, to verify B, A intersect B is equal to B, A times B, B. Is it equal or not? If equal, so we can conclude A, B are independent. So let's find B, A intersect B. Okay, using this info is a combination event B, A union B. The formula is BA plus BB minus BA intersect B. Given PA union B is equal to 0.8, BA 0.5, BB is 0.6. Okay, minus A intersect. So simplify. PA intersect B is equal to, bring to one side and bring 0.8 to the right, and 1.1 minus 0.8 is equal to 0.3. Done for this part. The next step is we're going to verify. Okay, is it this statement true? So next, find P A times B. PA is 0.5 times 0.6 is equal to 0. Okay, then here we check the value. Okay, PA intersect B is equal to 0.3. PA times PB is equal to 0.3. Then give the reason. Okay, since PA intersect B is equal to PA times PB. Okay, therefore, okay, A and B, just write this one, right? Okay, conclude. Are independent events. Okay, just follow this part. Okay, settle for number 1. Okay, number 2, it is found that 30% of population of an island are overweight. Among the overweight, the probability of those who do not have any chronic illness do not have is 0.4. And okay, for those who are not overweight, the probability that they do not have any chronic illness is 0.6. Okay, and draw a tree diagram to represent the given info. Okay, draw first the tree diagram. So, okay, let O is overweight. Okay, means that O prime or O bar is opposite, not overweight. And C is okay, have chronic illness. Means C bar or C prime is opposite. Do not have chronic illness. And then, okay, start here. Overweight, not overweight. Okay, chronic illness, not chronic illness. Chronic illness, not chronic illness. So given the info, overweight is 0.3. Okay, and okay, among this, do not have any chronic illness, 0.4. Okay, for O bar, okay, do not have any chronic illness is 0.65. Okay, this given info in this question, and we're going to find to fix this 0.7, so total 1, 0.6 total 1 probability, and 0.35. Okay, and for this part, draw a tree diagram, settle. For part A, and A, okay, and okay, 1A, okay, okay. If a person, okay, if a person randomly chosen from the population, find the probability that he does not have any chronic illness. Does not have any chronic illness. Okay, this one. Okay, and this. So does not have any chronic illness. Okay, so overweight, intercept does not have any chronic illness, plus P not overweight, and C bar. Okay, and here is 0.3 times 0.4 plus 0.7 times 0.65. Okay, and then calculate, find the value. So 0.3, 0.4 plus 0.7, 0.65, that is 23/40 or 0.575. Okay, up to you. You can give in decimal or fraction. Okay, done for the first A, part of A. And the second part, okay, the second part is overweight, knowing that he does not have any chronic illness. P, overweight, knowing that, means this is given, conditional. Okay, given that does not has chronic illness. So this is we call conditional probability. This one just now is P, only P, C bar. Okay, does not have chronic illness. But given overweight, knowing that, given that he does not have any chronic illness. So we're going to find P 0 given C bar. Okay, P overweight actually given C bar. Okay, so this one is equal to P overweight intersect C bar over P C bar. Okay, and 0 intercept this one. Right, is value equal to 0.3 times 0.4 over PC bar is 0.575, and then is equal to 0.345, 24 over 115, or in decimal 0.209. Okay, either one. Okay, and so for part B, okay, part 1, 1 person. Part B is 2 person. Okay, if 2 person are randomly chosen from the population, find the probability that both of them do not have any chronic illness. Means the person from first person do not have any chronic illness. The second person also do not have any chronic illness. Okay, this one of them. One of them means P. The first person do not have any chronic illness as chronic illness. Okay, and the second person has chronic illness, or probability C1 chronic illness, and the second person do not have chronic illness. And the third is at least one of them does not have chronic illness. Okay, so this one is answer for this part and also this part. Okay, 1 and 2. So at least one of them. This one both. Only one of them. Okay. So now we're going to answer this question using maybe simple tree diagram. Okay. Person, chronic illness, not chronic illness. The second person, chronic illness, not chronic illness. Chronic illness, not chronic illness. This is the second person. So chronic illness this is do not have. So we choose do not have chronic illness. C bar 0.575. So here is 0.575, 0.575, 0.575, and here is suppose 0.425 plus is equal to 1. 0.425, 0.425. Okay, for part B, B1, both of them. Okay, B, both of them do not have any chronic illness. So this one both of them do not have chronic illness. So P, C1 intersect do not have. C2 equal to 0.575 times 0.575. Okay, 0.575 square is equal to, or you can take in fraction. Yes, is 2340. Instead of using the decimal, you can take 23/40. Let's say this is equal to 23/40. 23/40. Then this one, so the answer is 3/40. So you to use whether to use the decimal or fraction. If fraction, you can the answer is equal to 529/1600. If decimal, then the answer is 0.331. Okay, this is 0. Okay, settle for part B1. For part B2, okay, only of them. Okay, this one. Only one of them. So P, only one of them is, okay, only one of them do not have. This one is only one of them has chronic illness. Okay. And P, C1 intersect C2 do not, plus P, C1 intersect P, C2. Okay, so this one we're going to do this. Okay, only one of them here. Also, okay, and use first. Okay, write this one. Okay, write in decimal or in fraction. Okay, use in decimal or fraction. Now I'm using the decimal. Okay, this one 0.425 times 0.575 Oh no, no, this is not included. The one of them, so this is not included. Sorry, only two. This one. Okay. Okay. See. Okay. And then plus C1 bar 0.575 times C2 0.425. Then the answer is in decimal is equal to 0.489. If you use a fraction, suppose you get 391 over, so it's 800. Okay, up to you. Okay, you can use a fraction or decimal. Okay, settle for that part. For part, the last part for this question is third one. At least one. Okay, at least one of them. P. At least. Okay, one of them does not have. Okay, at least one of them does not have. At least means that maybe two, maybe one. So, first, second, third. So, you have to add all or answer from part B, B1 or B2. Okay, B1 plus B2. Okay, or you can write as a new solution P C1 okay, C2 plus P C1 intersect C2 chronic illness okay plus P C1 intersect C2 both. Okay, and for this part answer here right here. Okay, this is 0.489 plus okay for this part both of them it is 0.331. Okay, 0.331 and is equal to 0.819. Okay, in fraction 1311 over 16. Okay, or you can take all. Okay, all this one is probability is equal to 1 minus this part. Okay, minus this. That both of them free from chronic illness. Okay, so C1 intersect C2. Or okay, P probability okay at least one C okay yang not chronic. So 1 minus P C1 intersect C2. Okay, so it's equal to 1 minus okay, C1 is C2 0.2425 times 0.425. 0.425 times 0.425 and is equal to 1 minus 0.425 is equal to okay, try to find this 0.425 0.18 and is equal to 0.819. Okay, 819. And this is actually got something here. Double check. 0.425 times 425. Oh, this is 1 actually. Okay. And then settle for this part. Okay, done. Okay, for chapter random variables, number 3, Nest works 5 days in a week. The number of days in a week she works overtime is a discrete random variable x with probability function. Given this one, this is discrete random variable. Z can be counted, x can be counted, 1, 2, 3, 4, 5. And given total probability is equal to 1. k constant, show that k equals 1 or 5. From the given function, okay, you can change to table. Okay, you see that x is equal to 0, 1, 2, 3, 4, 5. Okay. Check. Okay, 1, 2, 3, 4, 5, 6. So Px, probability x is equal to x, or Fx, when x is equal to 0, 1, 2, we're going to use this function. K over 3 modulus 3x minus 1. Okay, so substitute when 0, substitute 0, 3 times 0, 0, 0 minus 1, negative 1, so 1, 1 k over 3. It means this one is k over 3. K over 3. Okay, when x is equal to 1, 3 times 1, 3 minus 1, 2. 2 times k over 3, 2k over 3. This is 2k over 3. Okay, and when x is equal to 2, still here, substitute 3 times 2, 6, minus 1, 5, so 5k over 3. Okay, 5k over 3. When x is equal to 3, we use this one. Okay, the second function. Okay, and then here is substitute 3, 3 minus 2, 1, so 1 of k over 3. So this is k over 3, and x is equal to 4. 4 minus 2, 2k 3. So 2k over 3, 2k over 3. The next is when x is equal to 5. Okay, 5 substitute. 5 minus 1, 4. 4k over 3. Okay, 4k over 3. So when given given a discrete random variable, total suppose 1. Okay, the discrete random variable, total probability is equal to 1. Total is equal to 1. Okay, so total probability is equal to 1, or you can write when p x is equal to 0 plus p x is equal to 1 plus p x is equal to 2 plus p x is equal to 3 plus p x is equal to 4 plus p x is equal to 5, okay, is equal to 1. Okay, then k0 here is k over 3 plus 2k over 3 plus 5k over 3 plus, yeah, okay, k over 3 plus 2k over 3 plus 4k over 3 is equal to 1. Okay, you can skip this one, but it's okay. We want perfect solution. K plus 2k, 3k, 8, 9, 11, 15. 15k, 5k is equal to 1. Okay, 15 over 3. Therefore, k is equal to 1 over 5. Shown. Okay, shown. So, show. Okay, done. A, find the probability she works overtime every day in a week. So, would x refer to, okay, x refer to overtime. The number of days in which she works overtime is discrete random variable x. So, x refer to overtime. Overtime. And find the probability she works overtime every day. So 5 days. Okay, x probability x is equal to 5. X overtime X, random variable. X, strict random variable. Every day in a week, she works 5 days a week. Okay, this one 5 days. Here. So, find probability P X equals 5. Equals A, probability when X is equal to 5. So, from the given table, for K over 3. So, for K over 3, for K over 3 or for 1 over 5 K over 3 is equal to 4 over 15. Answer is 4 over 15. B, calculate the probability that she will work overtime for at least 3 days a week. Overtime probability, she at least 3 days. At least it is on 3. At least means that 4, 5, 6. 4, 5. Okay, so at least means 3 included. Okay, 3, 4, 5. So 3, 4, 5. X greater than included 3. B X. So B, probability X greater or equal 3, or P X is equal to 3 plus P X is equal to 4 plus P X is equal to 5. Then from table, we substitute K over 3, 2K over 3, 4K over 3. K over 3, 2K over 3 plus 4K over 3. Substitute. Repeat. 1, 3, 7 K over 3. Substitute 1 over 5. Okay, and the answer is 7 over 15. So for part B, for C, determine the most likely number of days in a week she will work overtime. The most likely number, that is, what to find? Mod. Mod is the highest probability. Okay, and check. Let's say substitute here. 1 over, let's say, find the value. Okay, 1 over 5, 1 over 15, 1 over 5, right? So it is 2 over 15, 1 over 3, 1 over 15, and 2 over 15, 4 over 15. This one is 5, 5 over 15. So the highest probability is this one when X is equal to 2. So mod is equal to 2. Okay. C is mod. Okay. Mod when X is equal to 2. Okay. So Px is equal to 2 is equal to 1 over 3. Okay. Determine the most likely number of days. So the answer is 2. Okay. E, find the expected number of day in a week she will work overtime. Expected number refer to EX. Okay, EX, expected number. Okay, and find EX. Hence, evaluate when E of 3x plus 1. So first, we need to find EX. So D EX. Okay, let's equal to total is equal to 1. So to find EX, EX. So the first this one 0 times 1 over 15. Okay, up times down. Okay, plus 1 times 2 over 15. Okay, here times, and plus. The next is plus 2 times 5 over 15 plus 3 times 1 over 15 plus 4 times 2 over 15 plus 5 times 4 over 15, and is equal to 0 plus 2 over 15 plus 10 over 15 plus 3 over 15 plus 8 over 15 plus 20 over 15. 0 plus 2 plus 10, 12, 15, 23, 43. 3 over 15, or 43 over 15 is equal to 2.87. Okay. The next is hence find E expectation 3x plus 1 by property take 3 outside times EX plus 1. Okay, whatever answer here, substitute. Okay, substitute 3 times 2.87 plus 1. So here is 3 times 2.87. So the answer is 9.61. Okay, settle. Number 4. The continuous random variable x has cumulative distribution function. Okay. And given the piecewise cumulative, this is continuous random variable x. A constant, show that A is equal to 4. Okay, show A is equal to 4. And here, okay, or you can transfer this one to number line. Number line for cumulative 0. For the 0 is 0 function. 0 to 1. Okay, included function is A third x power x cube minus 3x squared. This one 1. Okay, 1. So now here, let's say we choose okay, this one show that they share the same value when x is f of 0 is equal to 0, or substitute on the right hand side f0 a0 minus 0. So this one nothing, right? So proceed to then this number when s is equal to 1. When s is equal to 1, okay, and then substitute f of 1 on the left hand side using this function 1 cube minus 3 1 squared is equal to a minus 3. At this on the right hand side, f of 1 is equal to 1. So this is continuous. It implies that a minus 3 is equal to 1. Therefore, a is equal to 4. Settle for a. Okay, for the first part. For a, calculate the mean and variance. Mean is EX expectation. Okay, and variance means you need to use this formula. Variance x is equal to EX squared minus EX squared. So, okay, besides you find this EX, you need to find EX squared. substitute in this formula, then find the variance. Okay. Part A. To find EX, okay, the formula is integrate from negative infinity to infinity x times fx dx. So next we're going to find fx from the cumulative. So to find this one, fx, you need to differentiate the cumulative. That is ax cubed 1/2. Okay, so this is 3/2 minus 3x squared. Differentiate. Okay, we differentiate this one. This function. Okay, differentiate this one is 0. Differentiate 1 also 0. So let's find the value of x. Differentiate. Okay, this is 3/2. So from 3/2 x 3/2 minus 1 x minus 6x. So simplify. Okay, this one is 6 1/2. So set x minus 6x. This is the function. So we're going to use this function to find expectation. Okay, let's say if you do change to number line. Okay, 0, 1, and this one is fx. Fx is equal to 6x minus 6x, and okay, differentiate 1 0, differentiate this one also 0. So the function is actually for fx. Okay. 6x minus 6x for the interval x lies between 0 to 1 and 0 otherwise. Okay, and now we're going to find EX. EX is equal to from negative infinity to infinity. Okay, so from negative infinity to 0, actually 0, plus 0 to 1, x times function 6x minus 6x. Okay, integrate respect to x, plus 1 to infinity also 0. Okay, and before integrate, expand 6x 1 plus half is 3/2 minus 6 squared. Okay, integrate. Okay, 6x 5/2 and 2/5. Okay, plus 6 cubed over 3. Okay, from 0 to 1. And we substitute this is 12/5, 1 minus 2 and minus 0. So simplify 2/5. Okay, 12/5 minus 10/5, 2/5. Settle for EX. So now to find variance EX squared minus EX. Okay, this part done. We need to go find EX squared. So using the same procedure. Okay, EX squared. So everything same like this, same like this one. Times x, another x. So 0 from infinite negative infinity to 0 plus 0 to 1. Now this one is x squared. Okay, times 6x minus 6x. Okay, and then respect to x plus 0. Okay, for 1 to infinity. Okay, and then that's that. Okay, simplify. This one is x. Okay, and then 5 over 2 minus 6x cubed dx. Then integrate 6x plus 1 is 7 over 2, 2 over 7 minus 6x over 4 over 4 from 0 to 1. Okay, this one is 12 over 7 minus 3 over 2 minus 0. Okay, and then find this one. This is equal to 3 over 14. Okay, so this is 24 minus 21. 24 minus 21, 3 over 14. So substitute this value into this, okay, and then find the variance. Okay, so 3 over 14 minus 2 over 5 squared, okay, is equal to 3 over 14 minus 4 over 25. Okay, now you can use a calculator. Answer is 19 over 350 or 0.0543. This one is for B. Okay. No, this is for 4A. Okay. Okay. Okay, this is B. The next for B is find probability x minus EX less than 10. X minus EX less than 10. This one B. Probability x minus EX less than 1 over 10. Okay, so now, okay, the value of EX from part A is 2 over 5. So substitute 2 over 5. Okay, less than 1 over 10. Simplify x less than 2 over 5, bring to one side, and this is actually and then find the value. The value is 0.5. Okay, x less than 0.5. 5 over 5 over 10 is equal to 0.5, or actually this one is equal to cumulative 0.5. Okay, cumulative 0.5. At 0.5 is here. Okay, and then substitute in the formula here. Just substitute. Okay, substitute. A just now is 4 and third cube minus 3 squared. So substitute 0.5. 0.5. Okay, and find the value, and the answer is 0.664. 0.64. Betul? For part 4C, okay, if y equals 4x minus 3, find EY and variance y. So from here, you just use property. You don't have to find the new EY and variance EY and recalculate. That means that you find this one using the property. So EX is equal to 2 over 5. Okay. C, given y for x minus 3, find EY. Now y is 4x minus 3. Using the property for EX minus 3 and then EX. Okay, from this EX is equal to 2 over 5. 2 over 5. Okay, so 2/5, and this is 8/5 minus 3, and calculate, you can use calculator. Negative over 5, is over 5, or 7/5, or negative 1/4. Done? Okay, the last part, variance. Okay, variance y is variance for x minus 3. Body the property for squared while x 0. Okay, so 16 variance x. So before this, variance x is equal to 0.0543. 0.0543. Then find. Okay, this one is equal to 0.88688. For y, settle for this number. Okay. Number 5. On average, a hospital receives 6 emergency calls in 50 minutes. It is assumed that the number of emergency calls received followed by Poisson distribution. So let x number of receiving and emergency calls in 15 minutes. So x Poissonly distributed. Okay, so lambda is equal to 6. Okay, this one given in the first sentence. Okay, and for part A, find the probability that not more than 15 emergency calls are received in an hour. So an hour means 60 minutes, not more than 15. So for part A, we're going to find new lambda. Okay, so part A, we're going to define new variable. Let y, or you can use x also, number of receiving and emergency calls in 60 minutes. 60 minutes. This is 60 minutes. So y was only distributed. We're going to find new lambda. Okay, and when lambda in 15 minutes, lambda is equal to 6. Okay, and in 60 minutes, 60/15 times 6 equal to 24. So lambda is equal to 24. Write 24 here. Okay, and then not more than 15. Not more than 15. 15. Not more than 15. 60 cannot more than 15. So 14. 10. So right here to the left, can 15 included? Not more than 15. So 15 is included. Okay, and then so find the probability that x, or we use the variable y. You can use variable x. Y less or equal 15. Okay, so now this one is equal to or 1 minus, so 1 minus p y greater more or included 16. The first number is 16. Okay, here is not included. Okay, this is 16 onwards. Okay, here this part. Okay, then find the probability. Okay, from table, lambda is equal to 24. And Y more or included 16. The table 24, 16. Okay, here 24. Lambda 24. Okay, find the 16. 16 here. 24, 16. Okay, so this is the value 0.9656. 0.9656. So 0.965. So it's equal to 0.0344. So it is answer for part A. Part B, find the number of emergency call received M if it is known that the probability at most the M emergency call is received in half an hour is 0.155. In 30 minutes, then the probability is 0.55. So P at most, okay, in 30 minutes, probability is 0.155. At most, at most. Okay, discuss this one. Number 5B. 5. Okay. So at most. Okay, at most M. This is M. At most M. So this is to the left. P A X less or equal M is equal to 0.155. We need to define what is X. So X here is number of receiving an emergency call in 30 minutes. Okay, and for the first lambda, okay, in 15 minutes, the lambda is equal to 6. In 30 minutes, 30 over 15 times 6 is equal to 12. So lambda is equal to 12. So now we're going to use this one is X horizontally distributed, lambda is equal to 12. Okay, for this question, we're going to use this lambda. Okay, so now, okay, all 1 minus the probability, this part minus this part is equal to 0.155. So now 1 minus Px greater or equal. Okay, the next number here is, okay, here is M plus 1. So the blue is included to the right, M plus 1. Okay, while here between here is not included, this is discrete. Okay, and it's equal to 0.155. Okay, and try to simplify. X greater or equal M plus 1 is equal to 1 minus 0.155 is equal to 0.845. So here, okay, so from table, okay, we're going to find probability that X greater to something is equal to 0.845. Okay, check table. 0.845. Okay, lambda is equal to 12. Lambda is equal to 12. Okay, here 12. So here find 0.845. 0.845 here. 0.845. So X is equal to 9. Okay, from table, when Px greater or equal 9, the probability is 0.845. Okay, X greater than more or included So, from table, okay, Px greater or equal 9 is equal to 0.845. It is implying that this value is equal. Okay, m plus 1 is equal to 9. Therefore, m is equal to 8. Answer is 8. Settle for this number. Number 6. The probability that a type of antibiotics can cure a certain disease is 0.95. A. If 5 patients are given the antibiotics, find the probability that exactly 3 patients are cured after finishing the course antibiotic. So now, patient can be counted. So we can say this is the variable is under binomial distribution. So define the variable. Okay, let X number of patients are cured after given the antibiotics. So now X is binomially distributed. There are, this is A, part A, 5 patients. Probability 1 patient cure after given the antibiotic is 0.95. Probability that the type given antibiotic cure 0.95. So one success is the probability is 0.95. Okay. So A, exactly 3 patients cure after finishing the course of antibiotic. So now we're going to find probability X is equal to 3. Exactly 3. Using the binomial formula 5C3. Okay, the number of success, probability success, and 1 minus this one 0.95, that is 0.05. So 5 minus 3, 2. Then okay, this calculator, the answer is 0.0214. Okay, settle for this part. Part A1. Okay, for part A2, at least 1 patient cure after finishing the course antibiotic. At least 1. Okay, at least 1. Okay, at least 1. Can 2? Yes, can. Okay, so on the to the right, at least 1 can be taken. So means that you need to find the probability X greater or equal 1. Okay, so this one is equal to, okay, there are 5. Okay, 5 patients. So the number is from 0, okay, 3, 4, 5. So either you find P, and you can take this one, P X is equal to 1 plus P X is equal to 2 plus P X is equal to 3 plus P X is equal to 4 plus P X is equal to 5. Okay, here, 3, here, and here. 1, 2, 3, 4, 5. 1, 2, 3, 4. Or okay, this probability, okay, all 1 minus this one only, minus Px is equal to 0. Or you can take this one, Px greater or equal to 1 is equal to 1 minus Px is equal to 0. So up to you. You can use this one, okay, find 1 by 1, or this method. Okay, this one may be easier than this compared to this. Okay, and then next step, substitute. Okay, here is 5C0 0.950 and 0.05 power 5, and then this one is equal to 1 minus 0. This one almost 0, 0.000003125, or almost 0. We can say this one is actually 1 minus this one, this number, okay, is equal to 0.99999 something, or almost 1. Okay, total for this part. Okay, 500 patients given antibiotics. Find the probability more than 480 patient cure. Okay, so we're going to find the probability. Okay, P X more than 480. Okay, so now the same this is binomial distribution. Okay, X binomially distributed, and there are n is equal to 500. Probability 1 patient cure is 0.95. 0.95. So now this is very big number. So change approximate to normal distribution. Okay, the normal distribution is X normally distributed. This is mu and sigma, or sigma square. Okay, and sigma square is equal to variance sigma deviation. Okay, mu is equal to NP, and sigma square is equal to NPQ. Okay, find the value mu. Okay, and then the value mu is 500 times 0.95 is equal to 475. Right? And for this one, sigma square 500 0.95 and 0.05. Okay. .05, and find this one, the total is equal to 23.78. So write down this one. Okay, X normally distributed 475 and 23.78. Okay, this is sigma squared. Okay, sigma squared. But make sure find the square root. And the next is this is actually binomial. Okay, discrete. We want to change to normal. Okay, normal is continuous. So the number line, okay, 480 more than 480 more than. So starting the next number is 481. 481. So half here. If you should take here, the value is 480.5. So we're going to find Px more than 480.5. This is in binomial. Now this is changed to normal. Okay, and the next step is, okay, standardize. Okay, Pz. Okay, standardize in Z. 480.5 minus, okay, minus mean mu 475 over, okay, standard deviation 23 over 78 natural square root of this one, variance. And the next step, okay, Pz, calculate this one, find the value 1.13, and check the table. Check table, the value here, Z more than 1.13. 1.13. This is Z. 1.13. 1.13. So the number, the value is 1292. 1292. Okay. 292. Okay. This one is equal to 0.129. Settle for this part. Okay, settle for this part. For the next part, B, the largest possible value n such that the probability that at least n patient recover after finishing the course of antibiotics is 0.9. At least. So this is n. At least included, right? At least n included. So here is P X more or included n. The probability is 0.9. Okay, this one. Okay, number 6B2. X still binomially distributed 500. Probability 1 success is 0.95. Okay, now want to find X more or included n equal to 0.9. This is binomial. Okay, then n, this is n. Okay, from discrete to continuous, we need to do a continuity correction. Okay, so P X greater than, here starting here is minus 0.5 and minus 0.5. Okay, is equal to 0.9. Quantity correction. Then next step we try to standardize. Okay, standardize. Change to variable. Okay, in normal. And minus 0.5 minus mu. Mu is equal to 475 over square root of 23.75. Okay, and change to z, right? Z. No, this is x. X normal distributed, normally distributed, and this is 475, 2375. Okay, and the next step is actually check or find the value. Okay, this value, okay, is equal to 0.9. Okay, write down the best shape. Best shape 0.9. Z more than something. So here half here is 0.5. Okay, when 0.9, the region is starting maybe from here. Okay, starting here there is 0.9. So the another value here is negative. Okay, let's say this value is negative. Okay, let's say this is m. The value m suppose negative. Okay, I rewrite. P Z more than m is equal to 0.9. Okay, and m is equal to, and this m is equal to n minus 0.5 minus 475 over square root of 23.75. Okay, so from this one we're going to find 1 minus, okay, 1 minus P Z less than negative m is equal to 0.9. And here is negative m according to this bell shape. So P, okay, Z less than negative m, simplify, is equal to 0.1. Okay, or from table, P Z greater than m is equal to 0.1, and find m. Okay, find m. We're going to find m. Okay, 0.1. Okay, you can use a table. 1, 0.1 here. Check the last page of the table. 0.1. Okay, m is equal to 12816. 12816. Okay, m equals 12816. Or you can find from this table 0.1. The here find the probability 0.1. The probability 0.1 is equal to, let's say here, and this is the probability 0.1. Here is 1 to 8. Okay, 1 to 8. Here from inside to outside, this is probability. We're going to find m. M here is equal to 1.2, 8. 1.28, or you can take the last page of name table and find this one is 12816. Okay, direct. And then here from table, okay, P Z more than 1.28, okay, 16, okay, is equal to 0.1. So we want to find this one. Okay, this one because the ori is m lies on the left hand side. Here. Okay, so now it implies that negative m is equal to 1.28. M is equal to negative 1.28. So what is m? Okay, substitute here. M is negative 128 is equal to n minus 475.5 over square root of 2375. And find the value. Okay, here, and now you can get n is equal to, okay, find for you, negative 6.2379, okay, minus and plus, okay, bring to one side, plus 475.5, okay, plus 475.5, and the answer is 469.26. Okay, 469.26. So now n, what is n? N, this is n. Okay, and here is, okay, this is n, and to the right. Okay, the at least. So n now is 469.26. Okay, and the answer is, okay, check question, largest possible value of n. Largest possible value of n. Okay, so largest possible value of n is, okay, so here is 469. Therefore, n equals 469. This is the largest value. So that the other one. Okay, so the answer is 469. Settle for this part.